Hi guys, so yesterday you did an exploration worksheet talking about complex numbers and their operations to get you to have a chance to look for patterns and see how complex numbers work. So, the square root of -9, up until now, whenever you took an even root of a negative number, I told you to write it's not real or cannot be done. However, sometimes when we are asked to solve equations in algebra, we have a solution that equals the square root of a negative number. So, for instance here, if you were asked to solve for x squared plus 9 equals 0, when solving this, moving 9 to the other side, you have x squared equaling a negative number. So taking the square root of both sides. X equal, well, we have a square root of a negative number. The square root of -9. Up until now, we would say not a real number. And it isn't a real number. We can't take a square root of a negative. However, mathematicians came up with a notation that represents the square root of -1. So there's a notation here. Mathematicians came up with the variable I that represents the square root of -1. So back there, if we had the square root of -9, we can do the square root of -1 times the square root of 9, so 3i, this being representing I. So it just makes it look a little bit nicer, and it represents the square root of -1. So if I equals the square root of -1, then what would I squared be? So I equals the square root of -1, I squared, squaring both sides. What is the square root of -1 squared? Think back to when we took the square root of 2 squared. What happened to the square root? If you said it's released, correct. So I squared equals -1. We're going to use this more when we get into multiplication and division of complex numbers. So make a note of that. All right, the definition of the square root of -a. If a is a positive number, the principal root of a -a, you take out an I. I represents -1, and then you deal with the square root of a as normal. So if we have the square root of -25, that would be I, and then the square root of 25 is 5, so 5a. Notice I put the 5 in the front. We treat I just like a variable. It would look weird if we wrote I5. If you have the square root of -8, yeah, now you have the square root of 8. You use the same rules we did with simplifying. So square root of 8, 8 is not a perfect square. 8 is 2 cubed. So the square root of 2 cubed, we can take 1, 2 out. 1 has to stay in. There's only 1 here because it was a group of 2's, and then the I. So the square root of -8 would be 2i root 2. The definition of a complex number. We can have a real part and an imaginary part. This will come up when we have some examples coming up shortly. So a is a real number. bi is the imaginary part. So an example of a complex number is some examples of complex numbers would be 2 plus 5i, 4 minus I. All right, so the imaginary part is the piece that has the I. Notice for this one, it's a little weird because we're used to standard form having the variables first and the constants last. For complex numbers, the constants come first and then the variable part comes second. All right, so let's simplify some here. So let's do the first one together. The square root of -16. The square root of 16 is 4, and the square root of a -1 is I. So 4i would be the final answer. Number 2, separate them individually. Simplify them individually, excuse me. So the square root of 36 is 6. And the square root of -49 is 7i. Number 3, both the square root of 8 and the square root of -32. They are not perfect squares, but you can simplify them individually. What would the square root of 8 be? If you said 2 root 2, you are correct. Minus stays minus. The square root of a negative 1 is I. And 32, we have some work to do, so let's break that up. 32 is 16 times 2. If you notice that 16 is a perfect square, you can go ahead and just write that as 4 root 2. If you need to, you could have said 2 to the 5th and take out 2 groups of 2 and leave 1 left over. In standard form, some books you will see it as 4i root 2, or if you wanted it of the form a plus bi, other books write it as 4 root 2 with an I right after it. Notice you cannot combine like terms because this one has an I and this one does not. So these stay separate. Most of my answers will have this one as the form, just because I don't like the I after the square root, because then sometimes it looks like the I is inside the square root, which does not make sense here. All right, so that's for simplifying. Now let's take a look at some operations, which you guys had learned yesterday doing this stuff here. All right, so adding and subtracting. All right, so let's look at adding and subtracting complex numbers. Yesterday you guys looked for patterns to see how the operations worked. So if you noticed when adding and subtracting complex numbers, you add the real part and then you add the imaginary parts together. The imaginary parts. So you really are just treating your complex numbers when adding and subtracting just as if I is a variable. So 7i and 12i, they're like terms, so you combine like terms. So here, if you have to, and you are given some square roots of negatives, make sure you always take an I out. For now, you will never leave an answer with the square root of a negative number. You will have I in your answer instead to represent that. So, number 1, you are subtracting complex numbers. So step 1, distribute this negative 1 to each piece of your second complex number. So negative 5 plus 9i is being added to negative 6 minus 5i. So you just combine like terms. So negative 6 and negative 5 is negative 11. And then negative 5i plus 9 is 4i. So this is your final answer. Number 2, you first have to simplify your square roots. So what is the square root of negative 36? If you said 6i, you are correct. This first one is 6i, and this one is 3. The square root of negative 81 is 9i. Then distribute the negative and finish this off combining like terms. So go ahead and try that example on your own. If you said 6 minus 15i, you are correct. Notice once I distribute that negative, I don't need the parentheses anymore. The parentheses are really just separating your two complex numbers, but just be careful to always distribute your negative sign. All right, for multiplication, the main thing we need to remember with multiplication is when you get I squared anywhere, you have to make sure you remember that that equals negative 1. So you change that. So you never want to have any exponents on your i's. So for number 3, 6i times negative 7i would be negative 42i squared. But I just I squared is negative 1. So we have negative 42 times negative 1. So your final answer for this one is 42. For number 4, multiplying, you are allowed to multiply when you are taking the multiplication, the product of two things that are the same root. So number 4, they are both the square root. However, when you have the square root of negatives, you first have to simplify and take out i's. So the square root of negative 1 is I. Root of negative 16 is 4i. Now you multiply, and this is 4i squared. And we just learned I squared was negative 1. Do you need to always do this step? No, you can always just change it to negative 4. Negative 1. So this is your final answer. Do you need to show this step here? No, You don't have to. As long as you know what's going on, you can go right to changing the coefficient to its opposite. Number 5, you are multiplying 2i to the expression 4 plus I. So you're distributing 2i. Pause this and try out this example problem. If you got 8i minus 2, remember you have to change I squared to a negative 1, so that becomes negative 2. And then for standard form, you need to write the real part first and then the imaginary part. There's no sign in front of the 8i, it's positive, so make sure you put a plus sign. So that would be your final answer. Is 8i minus 2 wrong? No, it's just not in standard form. So standard form, your I term would come second. All right, so now we're going to be FOILing and multiplying out binomials that have I. So let's do number 6 together. So we have 7 minus I being multiplied by 3 plus I. So we have to FOIL. So 7 times 3, 21. 7 times positive I is positive 7i. Negative I times 3 is negative 3i. And then negative I times positive I is negative I squared. You have to combine like terms and also change I squared to a negative 1. So you have a negative I squared. So that's a negative negative 1. So negative 1 times negative 1 is positive 1. Combining like terms. Positive 7i minus 3i is 4i positive. And we have this 21 here. Combining like terms, you need to now combine these guys together. So your final answer is 22 plus 4i. For number 7, 2 plus I squared. We are not saying that that's going to be 4 plus I squared. You can't just distribute the 2 to both terms. This means you are multiplying the binomial 2 plus I times 2 plus I. Go ahead and take a moment and simplify this one out. If you said 3 plus 4i, you are correct. Just remember, we need to change I squared to be negative 1. Combine like terms of 2i and 2i makes 4i. And then combine the constants now. 4 minus 1 is 3. So that is operations of complex numbers with addition, subtraction, and multiplication. Tomorrow we will be doing division and of complex numbers. Let me know if you guys have any questions. Thanks, guys.